Next topic is normal distribution. This is a topic from which you will get questions in theory as well as practical. In theory, normal distribution is a short note. In practical and even in Viva, you will get questions from this topic. Okay, so let's see what is normal distribution. As the name indicates, it is a distribution which is considered as normal. If you look at this distribution, you should be able to say, okay, here we are dealing with normal values. Also known as Gaussian distribution. And this is a distribution in the arrangement of data. So when you arrange the data and if you see that shape, you should understand here we are dealing with normal data or normal individuals. And what is the distribution? How will it look like? In your standard textbook, they have given the shape of normal distribution. Something like this. Right? This is known as normal distribution curve. Yes, this is how a normal distribution curve will look like. You have a peak at the center and two tails of almost equal size on both, or equal length on both sides like this. Okay, so this is the shape of normal distribution. Okay, peak in the middle, two tails on both sides. Now my question is, why do you say this is normal? To understand why this shape you call as normal, let's consider one example. Imagine that I want to do a study to find out the height status of males in city X. There is a city X and I want to study the height status of males residing in city X. Ideally, I should be measuring the height of each and every man in that city X, and I have to measure their heights and plot, right? But that is not possible. That is not feasible. So what I'm going to do is, I'm going to take a sample of 1,000 men. Instead of taking every male, I'm just going to take a sample of 1,000 males from that population, and I am plotting their height like this. So this is the height distribution of 1,000 men in city X. First question. What do you call this distribution as? We've already seen this in presentation of data. What is it? This is histogram. Now, why this is histogram? Because we know height is a continuous variable, right? Okay, so this is a histogram showing height of 1,000 males in city X. Next, what is your interpretation? Of course, you know how to interpret the values from a histogram. We know that majority of males are having height between 167.5 and 177.5, right? Those males having height between 162 and 167, 172 and 182. 177 and 182 are less compared to this majority, right? And those males having height between 182 and 187, 157 and 162 are again less. And those males having height less than 155, see, less than 155 and more than 185 are rare, right? Yes. Next, I'm going to make a frequency curve from this. How can I do that? Again, we have learned in presentation of data how to make a frequency curve from a histogram. Find the midpoint and midpoint at the top of each bar. Then you draw a line like this. That makes it a frequency curve. Now, what is the interpretation? Same as the interpretation, right? I haven't made any change in the data. Only thing is that from the histogram, I made a frequency curve. What about the interpretation? Same. Majority are having height between 167 and 177 and likewise. Right? Okay. Now, this looks like what? This looks like a normal curve. I said in a normal curve, you have a peak at the center and two tails on both sides of almost equal length. So, this is a normal curve only. So, this is how you get a normal curve. Okay, is it clear? See guys, it's not just height. You take any variable in nature, let it be height or weight or IQ or hemoglobin or cholesterol or whatever. See, the nature has a tendency to keep everything within normal limits. The more you move away from normalcy, less will be the number of people having such values, right? And the farther the value is from normalcy, one of the rarest it will be, right? So if I am coming to your class, okay, your MBBS batch, and I'm taking the student's height or weight or IQ or hemoglobin, and if I plot a frequency curve, I will be getting something like this. Okay, a peak at the center, I'll be getting something like this. Okay, a peak at the center and two tails of almost equal length. And what do you have along the y-axis? Yes, we have frequency number along the y-axis. And some variable, let it be height or weight or, like I said, cholesterol or hemoglobin along the x-axis. X, you have the variable. Right. Now, what do you mean by this? See, the values which are falling under the peak are the majority, right? That means these are considered as normal values. And the values which fall under the tail are considered as kind of away from normalcy. That constitutes the tail, right? So if I take the IQ of students in your class, I'll be getting a normal curve with a peak at the center and two tails on both sides. And the values which fall under the peak are considered as normal values, and the values which fall under the tail are considered as abnormal values. And the value which fall under, suppose I am going to call this as right and this as left. The values which fall under my right tail are the values which are more than normalcy, and the values which fall under my left tail are considered as less than normal, right? This is more than normal and this is normal, right? So these will be the normal values. This is what is the concept behind normal curve or normal distribution. So if you see a peak at the center and two tails, consider it as normal. Okay, I hope you're with me. Let's see what are the characteristics of a normal curve. It's bilaterally symmetrical. That means if you cut it at the center, one side will be same as the other side. Okay, one will be the mirror image. Bell-shaped curve. Yes, you know that shape is bell-shaped. Highest point of the curve represent mode. We have already seen mode means the highest one. In a normal curve, usually all the measures of center tendency, mean equal to median equal to mode, will be the same number. They usually fall at the center. Okay, and mean, median and mode will be almost same value only. That means you have equal number of values which are less than the average on one side and equal number of values which are more than average on the other side. So they will be almost similar. And curves will not touch the baseline, right? The curve will not touch at the baseline. The assumption is that at somewhere in the infinity, they are touching the baseline. These are the characteristics of a normal curve or normal distribution. And in a normal distribution, you apply something known as 3 sigma rule. 3 sigma rule. And using 3 sigma rule, you can describe your sample. In my particular example, we were dealing with sample of 1000 males, right? Okay. Now let's see how to apply 3 sigma rule and what is 3 sigma rule. We have already seen what is sigma. What is sigma? When we were measuring or when we were studying about measures of center tendency and dispersion, I have said it back then. What is it? Sigma is the notation for standard deviation. In a normal curve, it is said that if you know mean is at the center. Can you see? If you know mean and standard deviation, then mean plus 1 standard deviation minus 1 standard deviation. That means plus 1 minus 1 from that mean value will include 68.26% of values in the data set. If you go for 2 standard deviation, mean plus 2 minus 2 standard deviation. That means you add 2 standard deviation to mean and you subtract 2 standard deviation from the mean, you will get a range which will include 95.46% of values in your data set. And if you go for 3 standard deviation, that means plus 3 minus 3, that will include 99.73% of values in your data set. Is it clear? This is known as 3 sigma rule. And I'm going to apply this 3 sigma rule in my 1000 males which I have taken from city X to describe the height.